everyone, welcome to AWS session. So today we'll be starting one of the products, in fact the flagship product of AWS, EC2, which is Elastic Compute Cloud. So I'll be starting Elastic Compute Cloud, and if you have any questions you can ask me in between or at the end of the session. So this is our agenda. What is EC2? What is ARMY and the different types of ARMY? ARMY is Amazon Machine Image, so we'll be discussing it later on. So EC2 pricing models, how the pricing works, key terminologies like security groups, key pairs, Elastic IPs, and then finally we'll conclude today's session with a demo, a practical demo of EC2. So what is EC2? So if you have a computer, or if you have say Macintosh, and you want to have Windows operating system on top of it, so there are two ways to do it. One is you go ahead and buy a Windows computer, and the second option is you install VMware on top of Mac, and then install Windows on top of VMware. So VMware is in hypervisor here, and the Windows operating system is a virtual machine which is running on top of your Macintosh operating system, right? And you can install as many operating systems as you want, as long as your underlying hardware, when I say hardware, I mean RAM, CPU, and hard disk, supports the virtual machines. So EC2 is exactly similar. The difference being that instead of VMware, we have something called Xen hypervisor, and we do not have any operating system underneath Xen. So let me draw a picture. So you have, this is your hardware. When I say hardware, I mean CPU, RAM, and hard disk also. Obviously, there are a lot of other things, but we'll not go into complications right now. So in case we have Mac OS, we want to install Windows and Linux. You can. These are the virtual machines. This is the Windows virtual machine. There's a Linux virtual machine, and here we have something called VMware, right? So, and VMware is running on top of Mac, and on top of VMware we have Windows and Unix or Linux virtual machines. So now let me bring it to the AWS world. So we do not have Mac operating systems anymore, or any operating system for the matter. We have a hard disk, and top of it a hypervisor is installed. So as you know, AWS uses something called Xen hypervisor, and on top of it you can run as many operating systems as you want. It can be Linux, it can be SUSE, it can be Red Hat, it can be Amazon Linux, Windows, Ubuntu, whatever you like. There's no limitation on the underlying hardware as you might have if you run it on your own computer. So these things, these virtual machines, are called EC2 instances, right? So the name is EC2 instance, but the operating systems may differ. So you might like to have any operating system as you want. So as I say, EC2 gives you virtual machines in the cloud. So these are also called servers. So if you know what a server is, so it's basically a machine which has compute capacity and which has some persistent storage, right? So EC2 uses EBS as a persistent storage, which is our next topic of discussion. And the EC2 instances are launched in Amazon's data centers using APIs, which is application programming interface. So when we use, I have already shown you this the AWS console. So initially we'll be going ahead with the console, but yes, you can use CLI and APIs also. So if you're using CLI, you need to know the command line, and if you're using API, you need to know at least one of the programming languages or some HTTP tool, HTTP wrapper like Postman. So you can provide the API in Postman directly, and come and hit AWS, and you'll do whatever you want it to do, right? So now the thing is, you are allowed to use server instances at any time as long as you need and for any legal purpose. This is a very important line, or important point. So if you see something, there's something called on demand. That means, suppose I have a very small startup, or for that matter I have a very huge corporate enterprise. What I can do is, suppose for some reason I need a machine for say 1 week, right? And again, in 1 week you might not be using the entire machine. You might not be using the machine in the entire week 24/7. You might use it say on Monday, or on the first day you might use it for say 10 or 12 hours, and say Tuesday you might use it for say 5 hours, like that. So I hope you get the idea. Now the thing is, why does it call on demand? So forget about AWS as of now. What if you have to do it in a corporate data center? So you have to buy a machine, right? You do not have any other option. Either you buy it or you have to lease the machine, lease the server. So buying is definitely, that's permanent cost. If you want to buy a server, that suppose it costs, for example, the cheapest being $1,000. Okay, so some very basic laptop. Again, you're paying $1,000, and that's permanent. And if you're leasing it, if you're planning to lease a server, you have to lease it for at least 6 months or a year. You cannot lease for 1 week. There's no way. You won't find servers which are leased for a week. Here, things become interesting in AWS. So when I say on demand, I can use the server, I can start a server or a virtual machine, as we said, for 1 week. And the thing is, we can run it for, say, on Monday, we run it for 10 hours or 12 hours. On Tuesday, we run it for 5 or 6 hours. Wednesday sometime, Tuesday sometime. Now, say in the entire week, you have used for, say, 42 hours. Okay. And the week obviously is more than that, 24/7. The interesting part here is you'll be paying money only for 42 hours. You won't be paying it for the entire week. You won't be even paying it for the entire day. It's only for the number of hours which you have used. That is called on demand. And there are a lot of other options, which is called reserved instance, spot instance, which we'll be discussing later on. And of course, the primary concern might be like, yes, I'm starting a virtual machine. What would be the size of those machines? Like what would be the amount of RAM? What would be the amount of CPU which I'll be getting? So instances are available in different sizes and configurations, and it is scalable. So what I mean by that is, suppose you start up with an instance or a virtual machine with, for example, 2 gigabytes of RAM and say 1.4 gigahertz of CPU speed, or CPU clock speed for that matter. If you see that it's not sufficing your need, you can increase the size dynamically in EC2, using EC2 or in AWS. And so it's very easy. It's a click of some mouse buttons. That's it. Yeah, as I was saying, instances are available in different sizes and configurations, and you can scale it whenever you want. And so it provides an error shield. So what I mean by error shield is, suppose you are a solutions architect for your corporate enterprise or environment, and someone has said that we're getting a new application, and we want you to build the entire infrastructure bottom up. So what you have to do in this case is, you'll have to do the analysis with the application. What would be the workload? What would be the number of transactions? So on and so forth. A lot of other stuff, and you come to a conclusion that you might need, say, for example, 120 gigabytes of RAM, and say 5 terabytes of storage, and say 4 gigahertz of CPU. So if you are in an on-premise environment, you'll have to go and buy all the stuff or lease it. Right now, say after some time, you have or everything is done, you have bought all the hardware, you have leased it, applications are up and running. Now you come to know that you have over provisioned a lot. So what I mean by that is, so after 1.5 months, you see that instead of 120 gigabytes of RAM, your application is using only, say, 48 gigabytes of RAM, right? And instead of 4 gigahertz of CPU, it's only using say, for example, 2 gigahertz of clock speed. And storage, again, instead of 5 terabyte, it's using, say, 3 or 4 terabyte. So if you see 80 gigabytes of RAM will be wasted. 2 gigahertz of CPU will be wasted, and maybe 2 terabytes of storage will be wasted because you cannot return the hardware. Now, as AWS is scalable, what you can do is you can over provision it, not a problem. But after 1 month, if you see that your application is not using it, you can scale it down anytime. Yes, of course, you have paid for 1 month. You have paid for the over provision resource for a month. But again, that's only for a month. Had it been your corporate data center, you have to pay forever. You have already bought it. There's no way you can return back. Okay, so basically this allows AWS to provide different instance types, and depending on your need, you can choose the type of instance which you want to spin up, or the type of hardware, the type of resource you want for a particular application. And the thing is, as I say, it's pay as you go. You don't have to overpay or underpay. You pay as much as you use, and the minimum unit is one hour. So the minimum amount of payment is 1 hour. Even if you have used it for say 5 or 10 minutes, the payment will be count towards 1 hour. That's okay. I mean, that's still very fine, because given the flexibility which AWS gives. And trust me, it saves a lot of time compared to your data center. So at the end of this session, what I'll do is I'll show you if you use all the AWS products as opposed to a licensed server or licensed products on your on-premise data center, will be at least 50% of cost saving. And that's why AWS is so famous now. Cloud basically is so famous, and AWS is the most famous cloud provider. Right. These are some highlights which I have already spoken about. Elastic, EC2 is elastic, is flexible, secure, because the infrastructure, the security of the infrastructure is taken care of by AWS. You don't have to bother about it. If you want to host a HIPAA compliant or PCI compliant workload in your EC2 instances, that's fine as far as the infrastructure is concerned. Yes, the applications which you will be installing on top in EC2 servers or EC2 virtual machines, the security of those applications have to be taken care of by you. Again, still it takes off the burden of security of your infrastructure, and there are a lot of things involved in the security of infrastructure. It's much cheaper. And there's something called AMIs or AMIs or Amazon Machine Images. So Amazon Machine Images, we'll discuss Amazon Machine Images shortly. So it's to give you a brief, it contains an operating system, and it might contain a few pre-built software, also pre-installed software, and use that image to spin up your virtual machine, EC2 virtual machine or EC2 instance. So for example, you might have used Windows ISO files, right? So the ISO files or the ISO image, what it contains is the entire Windows operating system, bearing all the other softwares. But in case of ARMY, you can have your operating systems, you can have your own custom softwares also, and you can spin up your multiple EC2 instances or multiple servers using the same ARMY. So for example, suppose you have you have spinned up an Linux instance or Red Hat instance, and you have installed DB2, Oracle, or say an Java for that matter. Now the thing is, you can create an ARMY, or you can create an image of this machine which you have spinned up or which you have started with all the applications within it, and then use that image to start maybe thousands of servers. All will have the exact same thing: your Red Hat operating system, DB2, Oracle, and Java. And of course, it is reliable because there are a lot of compliance. AWS follows a lot of compliance, and the reports are there in their website. And if you want to check the compliance reports and stuff, you can go to AWS websites and check that. Okay, few definitions. There's something called ARMY. As I say, ARMY contains the image which will be starting the virtual machine with. So it can be an image of just an operating system or some softwares along with the operating system. So in typical cases, we'll be using ARMYs which has just the operating system, right? So any of the operating systems already there in the image, we'll be using that one to start an instance. Again, instance is in the virtual machine in terms of EC2, and we'll have volumes attached to it, so which is persistent storage. We can take snapshot of that volume, and then we can store it somewhere else also. So let us go for a demo. Any questions so far?
Hello.
Yes, Gaurav.
So sir, what if we don't want on-demand instance?
Yes, so that's a good question. Now, if you do not want on-demand instance, there's something called reserved instance, and there's something called spot instance also. So the scenario which I had given you, like if you want a machine for 1 week, so in that case, spot instance is something which will be which will be most favorable for your use case. And there's something called reserved instance also. Uh, what is the reserved instance? Is suppose you want an EC2 instance for say 1 year or for a very long term. So in that case, you get additional discount on top of the pricing which is provided by AWS. So your infrastructure will be much cheaper compared to on-premise data centers. So spot instance and reserved instance reduces the cost by 70 to 80%. So we'll discuss spot instance and reserved instance in details later on. So hold on to that question. So we'll come back to that again. So I hope you get the idea of what is the difference. What if you don't want on-demand instance? Yes, definitely you can go for reserved instance or spot instance also.
Hello,
Yes.
I'm Ashashri here. I have one doubt. Can you please explain me how the EC2 instances are started by AWS?
Okay, fine. So that's again a good question. So what happens here is, for example, let me give an analogy. Again, I'm going back to my first example wherein we have Mac operating system and I want Windows and Linux machines on top of it. So there are, as I say, two ways. One is you have your Mac machine, go and buy another Windows machine and buy another Linux machine. Or you install VMware on top of Mac and then spin up virtual machines with Windows or Linux operating systems. All right, now the thing is, you install it here, and so while installing, what we'll have to do is we'll have to give the operating system. We'll have to provide the ISO image or the disk where VMware will install the operating system from. Similarly, for Linux also it is the same. You'll have to provide either ISO image or a disk which VMware will use to install the operating system from. So in case of AWS, VMware is not there, and there's no Mac operating system. There's no operating system for that matter. We have the hardware directly. So on top of hardware, you have something called Xen hypervisor, and instead of ISOs, we have something called armies, what we have discussed now. So armies are kind of ISOs which contains the software where the operating system will be installed from. So what Xen does is it gets the hardware. You say, okay, I need say 2 gigabytes of RAM and some amount of CPU, say 2 or 3 or 4 CPUs for that matter, and some other stuff. Okay, so what Xen does is it gets this amount, 2 gigabytes of RAM and say 4 CPUs from this hardware and cuts a portion of it and uses that one. That is the first input to Xen, and the second input is ARMY. So where the operating system image is there. Basically, it's like Windows disk or Windows bootable disk, where you have your entire operating system and you use the disk to install your Windows system. So the Xen hypervisor uses both of these, and then whatever operating system you have asked for, it spins up that EC2 instance or EC2 virtual machine. All right. So if you want say Linux or Ubuntu, this virtual machine will use an ARMY. It has Ubuntu. So Xen hypervisor will use the Ubuntu ARMY, and then from that it has already the hardware specification. We get the hardware from the underlying hardware, which is there in Amazon data centers, and it will spin up an EC2 instance or a virtual machine with Ubuntu operating system in it. Okay, so now as an end user, you would never notice below this portion. What is happening behind the scenes, we'll never notice it. So as an end user, we'll get the experience of a server. That's it. we won't even know that yes, Zen is using this. The operating system has been installed from an army or so on and so forth. But I'll get an experience of a server. Okay. All right. So now I'll just I'll show you a demo. How to launch an instance. We'll see how to launch a server. We'll see that how easy it is, and I'll be discussing all the details of whatever you see in the screen. So this is where you log into AWS console, go to services and click on EC2. So this is a console. As a beginner, you should always use the console. Later on, when you are pretty much familiar with AWS, you should use command line. And in production environment you'll be mostly using command line, which I'll show you later on how to use command line, and we'll be using command line going forward. So launch instance, click on launch instance. This is something called, it says choose an army. Okay, so if you see here, it is asking me to choose an army or Amazon machine image. And the machine image contains Amazon Linux Army, SUSE, Red Hat, Ubuntu, Microsoft Windows. So these are the files where the operating system is there. So you might think of this thing as a as your boot device for, or say installation drive for the operating systems which I mentioned. So we'll select this one, and it gets us to this screen, which is choose an instance type. So this is what, as I was saying, the amount of CPU and how much hardware do you want, how much of resource do you want. Those are the things which we'll mention here. So if you see here, it says family. We'll discuss family later on, so ignore it as of now. There's something called type. These are the instance types. So if you see here, T2.micro is free tier eligible, which has 1 vCPU and 1 gigabytes of RAM. So it says currently selected as T2 micro, 1 vCPU, 2.5 gigahertz of CPU. CPU. The CPU is 2.5 gigahertz of speed and 1 gigabytes of memory. So let's choose something else. State changes. So it has 4 vCPUs and 16 gigabytes of memory. So it says 13 ECUs or 4 vCPUs. ECUs have been deprecated by AWS. So AWS uses vCPUs to provide the computing capability. So it says 4 vCPUs, 2.4 gigahertz each of Intel Xeon E5-2676 version 3. So it's basically, I think, Haswell, right? And 16 gigabytes of memory. Now we'll use this T2.micro. And there's something called storage. We'll come to storage later on, and then configure instance details. This is the networking portion. So this is where we'll mention what should be my network, in which network I should launch my server or EC2 instance in. All right. So you can select any of the networks. So we have created this Intellipaat VPC. You can use this one, and it has these subnets. And auto assign IP, you can enable auto assign public IP. Next, add storage. We'll skip it as of now, and then you can tag it, say name Intellipaat EC2 instance. Configure security group. As of now, we'll select default security group, which is allow everyone. This is a firewall. Basically, set up a firewall which will be used in the instance to block or allow traffic. So, all right. So then review and launch. We'll come back to this later on. And then you have your instance up and running. That's it. You have a server now. We'll see here Intellipaat EC2 instance. It is pending. It is in pending state right now. Shortly, it will be in running state, and you can log into it. So there's the demo, and I'll show you how to log into this instance, how to SSH into this instance, and then you can do whatever you will be doing had it been a server. So the moment you log into that EC2 instance, there's no difference. For you, it's a server. Any questions, guys?
Yeah, Soumyadeep, what is vCPU?
Okay, so vCPU, to discuss about vCPU, I'll have to tell you something about how our CPU works. All right, so a CPU has something called socket. Okay, so you have socket, this is your socket, and on top of socket, you have something called cores. These are the cores. And this entire thing is called a CPU. So CPU is not one processor, CPU is the unit on which the processors are basically sitting on. So we have socket, on top of it we have cores. Cores or processors. All right. Now the thing is, let's go a little bit deeper. Let's say one core. So the latest generation of Intel processors, which started with Nehalem, first generation. So earlier we had Pentium 1, Pentium 2, Pentium 3 kind of stuff, right? So right now the Pentium generation has gone. You'll see Core i7, Core i5, Core i3. So those are laptops and desktop processors. But for server side, we have the Intel processors. The Intel processors are named as Xeon. Now each processor, it started with first generation, whose name was Nehalem. And Nehalem introduced something called multi-threading. Now the thing is, how CPU works is, if you suppose you have 4 processors, so that means at any point in time you can run only 4 programs, not more than that. So if you see here in my machine, I have multiple programs running. Oh, sorry. I have multiple programs running here. 1, 2, 3, 4, 5, 6, 7, and a few others in the background. But I have only 2 cores. Now the thing is, how does it work? Now for human, so at any point in time, my computer is only running 2 programs, not more than that. We see it is a multitasking because the switch happens so fast that it's unreadable or unrecognizable by humans. So having said that, if you have 4 cores or 4 processors, your computer can run only 4 programs at a time. Now multi-threading changed that little bit. So each processor can run only 1 program, used to run 1 program. Multi-threading changed that. So in this case, each processor or each core now can run 2 programs or 2 processes at any point in time. It's not that, it's, again, don't confuse it. Suppose, if you might ask, that means that if the CPU clock speed is 2.6 gigahertz, that means each processor will get 1.2 gigahertz. No, that is not how it works. So and multi-threading uses the idle time of CPU much more efficiently. So it's not that, suppose you are running a program which takes say 1 minute, multi-threading will reduce it to half minute. No. So it's a little different. Again, it will take us to a lot more details in CPU. But each core, as I say, each core can have now 2 threads or 2 processes running. Now each thread is a vCPU. So if you see here, let me try to launch one more instance, and let's say here there are a few aberrations on that one. Whenever you say when you see one vCPU, if you click on this one, it has one vCPU. That means it is only one processor. It's not a thread. Whenever you see 2 vCPUs, that means there are 2 threads. Basically, 2 vCPUs are equal to 1 core or 1 processor. So if you want to, suppose someone tells you, the application team tells you, I need say 2.4 gigahertz of CPU with 4 processors or 4 cores, you will not choose T2X large. T2X large has 4 vCPUs and 2.4 gigahertz of CPU speed, but it is essentially meaning that these are 4 threads from 2 processors. So if you have to go for 4 processors, you'll have to select 8 vCPUs. An instance with 8 vCPUs. That is equivalent to 4 processors. All right. Does that answer the question? Now what I'll do is I'll log into that particular instance. There's something called keep here which we have not discussed yet, so I'll come back to that shortly. EC2 is not over yet. So now, if you see here, I'm in that particular EC2 instance. Now you can do whatever you want. You can install Apache. Sorry, you can install Apache. Apache is installed. Now, for you, it's nothing but a server. Plain raw server, nothing is installed, no program is there. You can install, go install say MySQL. If I don't know whether the package is there, it's not there. Or it's MySQL. Sorry. So yum install MySQL. So MySQL is getting installed. Now I have two softwares installed on this particular server. One is Apache and the other one is MySQL. All right, so from here you can create. Now if you create an image from this machine, you can do that. So go to actions, instance, go to image and create image. Now the moment you create an image from this one, again we'll come back to this later on, so just to give you an idea, so when you create an image, that image will contain not only Amazon Linux but also your MySQL and Apache. So next time, while launching an instance, I selected this particular image. If you want the exact same instance with MySQL and Apache, you'll be selecting your image, and then if you launch that particular EC2 instance, it will have both MySQL and Apache installed already. You don't have to do anything anymore. All right. Now, if you select this particular instance, you'll see there are a lot of descriptions. In the description tab, we have multiple tabs for a particular instance. We have description, we have status checks, we have monitoring, then we have tags. So if you go to this description, you'll see there are a lot of things. First is the instance ID. So I hope it's a no-brainer. You do not need, I don't have to tell you what an instance ID is. If you're working in an organization, you must be having employee ID. So this is the employee ID for this particular instance for your account. So which identifies this instance uniquely throughout your environment for your account. The state of the instance is running. Instance type, which you had selected, T2.micro, that because that was free tier, we could have selected something else, but in that case, we would have to pay something. Easy availability zone is US East 1A. Security groups, we had selected the default security group. I'll come back to this later on. We need a lot more details here. Then Army ID. So this is the ID of the Amazon machine image which you had selected. There are a few other stuff which I'll discuss in due time. But take a notice here on this stuff. We have 4 things. One is called public DNS, public IP, private DNS, and private IP. So how it works? Why do we have 2 DNSs and 2 IP addresses? So if you think about it, consider your machine. Okay, wherever you're sitting at right now, whichever country, if you're using internet, you must be having a router, and behind that router, you're using your machine, which you're using to view this particular session right now. Go ahead, if it's a if it's a Windows machine, go ahead and type ipconfig. If it's a Linux machine, go ahead and type ifconfig. So what I'll see here is, let me show you a little bit. So I'm in that particular instance. Let me come out of it. So this is my machine, and if I type ifconfig, it will show me I have multiple cards. So let me show you that my IP address here is 192.168.2.6. Now, if you type ifconfig or ipconfig, you might have also got something like 192.168. But this is not actually my machine's IP, which is seen by the world. So the entire world sees the IP address of my router, not my machine. So basically that means that my machine is sitting behind the router, or there can be multiple machines behind the router which belong to us, belong to something which is called LAN. So we'll discuss that in details in our VPC session, virtual private cloud session. But the public IP address is the address which is viewable by the entire world, and the private IP address or private DNS which is within the LAN. If I want, I can get a public IP address for my machine also, along with the router's IP address, but I'll have to pay some extra money to my ISP or internet service provider. So if we have to log in using this particular instance, log in into this particular instance, we'll be using the public IP only. We cannot use private IP. So if you see here, when I did an SSH, I used 54.224 to 5046. That is the public IP address, because I'm logging in from a machine which is not in the LAN of AWS data center. That's the public IP address. Now the thing is, these are very important stuff, and if you are hosting a web server or a web service for that matter, you'll be using the public DNS or private DNS. All right. So then we have secondary IP, subnet IP, network interfaces. Again, we'll be discussing in due time. So as of now, this is how EC2 instance works. Any questions so far?
Does the public IP address remain same throughout the life of the EC2 instance?
Okay, that's a good question. Now the thing is, this public address, I would have shown you this shortly. It's a good. Now the thing is, this IP address is assigned by AWS. It's not assigned by us. Now what? Let me stop this particular instance. I'm stopping this instance. So when you stop this instance, it will not be built. Stop does not mean you're wiping out the virtual machine. It's just in stop state. Now notice this particular place. Notice this IP address. What happens to this when I stop? When I execute the stop command, or I stop this particular EC2 instance. Okay, it is getting stopped. It'll take some time. So to answer your question, no, it does not. When I start this EC2 instance again, we'll have a separate public IP address. Now you might ask, what? Of course, that's dangerous. I mean, we are using IP address to the server might be hosting some, say, Nginx and Java, some web server, right? You're using Nginx plus Java, for example, or Apache Tomcat, and you have some application which is in some other machine, and that application is using this machine's IP address to access this web server. What if the IP address changes? That's dangerous, right? Yes, of course that is. So that's where elastic IPs come into picture. So if you allocate a new elastic IP address, you go to elastic IPs, allocate a new one, and then so I've got this elastic IP address which is 34.21, 231, 236, and 174. You attach this elastic IP to this particular EC2 instance, then it will not change anymore. So before that, let me just show you that the IP address changes. So earlier we had 54 to 24 to 5046. Now we'll have something else. So see, it has gone now. So that's a good question, but this elastic IP address will be discussed in the APC session.
Okay, sure.
Okay, so now if you see here, select this one. See, IP address is different. 54.175.8.112. Okay, so this is 54.224. So it has changed. Now what you can do here is, you have this elastic IP address, go to action, select this elastic IP, action, associate, and associate with the instance which is running. So Intellipaat EC2 instance, right? Associate. Now if I go and check my instance, so the public IP address is the one which I have just associated. Elastic. Now even if you stop and start, the IP address will not change. will be the same. So this is where your if you are using a public facing EC2 instance or server, you should use elastic IP address. And again, which is getting used by some other application, you should use elastic IP address so that your IP address does not change. If you can, and elastic IP address comes with a price. It's not free. You have to pay something for it. If you are fine with changing the IP address, then use the IP addresses assigned by AWS by default. But if you can't afford that one, go ahead and use elastic IP address. Okay, so even though the instance is getting stopped now, you'll see the DNS name will change, but the IP address will not. Okay, so the instance has been stopped. See, IP address is the IP address is same. It has not changed. Now, if I start, the IP address would be the same. If I start again, it will not change. Okay, sorry, the DNS will also not change because it is associated with the elastic IP address. So DNS, public DNS and public IP would be the same. No matter how many times you start and stop this particular instance, it will be the association would be there till the time you terminate the instance. So when you terminate an instance, the instance will be wiped out. You can't access it anymore. You can't get it back as well. So see, the IP address has not changed. So as long as you are not terminating, the association would be there. All right, so that's how you use EC2, and it's as I said, it's a flagship product of AWS, and a lot of EC2s are getting used over the world. Now people are, you'll see when I show you the pricing model, you'll see how cheap EC2 instance. It reduces the on-premise cost or your operational expenditure or capital expenditure by 70-80%. If you're using either spot instances or reserved instances. Okay.
Okay, thank you.
Okay, bye.